So today we're going to be talking about polyatomic ions and how to name them systematically. So the first thing on our list of things to talk about when we're talking about polyatomic ions is what's called ternary salts. But pretty much what they are polyatomic salts. What we learned in previous chapters is a salt is just an ionic bond. So what it is it's taking the anion polyatomic and it's ionically bonding it with the cation metal. So ternary salts consist of a metal ionically bonded to a polyatomic nonmetal. You'll just need to memorize the polyatomic ions. That's the only way about it. If you wanted to, construct your own, you could on a test, but you would have to calculate formal charges of each, and that gets long, drawn out, complicated, right? Especially considering that there's multiple different Lewis structures available for each polyatomic. You would have to be sure that you had it. It's much easier just to memorize. There's no way about it. You just have to memorize the polyatomic ions. Luckily for you, there's only a few that I will require you to memorize because there's only a few that we're going to consistently run into again and again and again. So the first thing about polyatomic ions is, just like we've discussed before, we treat them as a single ion, and that's all we treat them as. We don't treat them as a group of atoms. We treat them as a single atom almost. So it's like you're generating an entirely new element, but it just doesn't conform to the physical properties of an element. So it's a single cohesive group. We name it as such. So when we're naming ternary salts, an example MgSO4 would be magnesium sulfate, right? So you'll see polyatomic ions in parentheses, but that's only if subscripts are needed. So let's say we have aluminum sulfate. Aluminum has an oxidation state of +3. Sulfate has an oxidation state of -2. Therefore, it's going to be Al2SO4 3, right? So in that case, we have 3 of these polyatomic ions. We have 3 groups of SO4, which means that SO4 needs to be in parentheses with a 3 subscript. All right, so what we're going to be talking about today are the oxyacid polyatomics, which means oxygen is going to be in all of them. So if you look at these, we have the sulfate group, the chlorate group, the bromate, the nitrate, the phosphate, the carbonate. You'll also run into an iodate, right? So these are the common polyatomics, and these are the ones that you have to memorize. That's the only way about it. You're going to run into them probably 100, 150 times throughout the year, where you just have to know SO4 2- is sulfate. So there's no way around it. You just have to memorize it. So you only have 6 of them. You have sulfate, chlorate, bromate, nitrate, phosphate, and carbonate. But it's really easy if you categorize it, right? So chlorate, bromate, nitrate, that's -1. Sulfate, carbonate, -2. Phosphate, 3. So it goes 3, 2, 1. There's 3 -1s, 2 -2s, and 1 -3. So if you categorize it, you can memorize them really quickly. So when we talk about polyatomic ions, we talk about their oxidation state. That does not apply to each individual atom, right? We're talking about a covalently bonded molecule that has its own oxidation state. So just because there's 4 oxygens, that means nothing. That means absolutely nothing. We ignore the subscript 4. We treat it as one group. It's now the sulfate group, right? It's not SO4, it's the sulfate group. You really need to keep that in mind because a lot of students stumble over that. They stumble over the fact that they're looking at oxygen and they see 4 oxygens and they say, well, what is this about? How can I figure this out? And it's the sulfate group is what has the oxidation state. Doesn't matter what atoms are in it. So you got sulfate, chlorate, bromate, nitrate, phosphate, and carbonate. So now when you're looking at this slide, look at the common traits, right? In all of these, you can say that it's a metal, right? In the top portion, that's calcium. In the bottom, that's potassium. But you also have it bonded to a polyatomic. So these are ternary salts, right? So if you look in the first one, that's calcium sulfate up there. That's SO4, right? So now it gets the 8. That's calcium sulfate, right? That's calcium sulfite. And then SO2 is hyposulfite. So now this becomes very important because if you look down there, right, now locate the one with the 8 suffix. Well, that's BrO3. What's one oxygen less than BrO3? Well, that's BrO2. That's the bromite. So what's one oxygen less than SO4? That's SO3. That's the sulfite. So you notice there's a commonality in the suffixes, right? Ate becomes ite as you decrease by one, and then it becomes hypoite when you decrease by another one. And then you see perbromate. So now we have another section where you add a prefix and a suffix. So now we have our system of naming ternary salts. Number one, we name the metal, just like in binary compounds. Then number two, we name the polyatomic ion with the appropriate ending. That's the important part, and that's the entirety of ternary salts. That's the only difficult portion, right? That's the only difference. It's just like binary ionic compounds with multiple oxidation states, right? Just where we added the Roman numerals to represent the oxidation states of the transition metals. Well, now we're adding prefixes or suffixes onto the ending of our polyatomic ion to indicate how many oxygens there are. Well, a natural question that arises in students' minds is, how do we know how many oxygens go with what? Well, I'm going to tell you right now, it has a lot to do with chemistry that's beyond our grasp. So right now, what we're going to do is we're going to say, for the ion with the most common number of oxygens. And you have to memorize that. Sulfate is SO4. Bromate is BrO3. Chlorate, BrO3. Nitrate is NO3, right? You have to memorize those number of oxygens that go with the 8 ending. That's your common number of oxygens. So now everything is based off that number. So let's say NO2. That's going to get the ite ending because now that's one fewer oxygen. So now instead of nitrate being NO3, you're going to be the nitrite ion, right? But the charge does not change on the polyatomic. Doesn't matter its name, you're dealing with the same functional group, which means you're dealing with the same charge. So persulfate, sulfate, sulfite, and hyposulfite will all have the same oxidation state. The only thing you need to memorize is which is the 8 ending. The 8 ending gives you the common number of oxygens, and you can work from there. So SO4 is sulfate, SO3 is sulfite, SO2 is hyposulfite. Nitrate is at NO3. That means NO2 is nitrite. NO is hyponitrite, right? So it's based off the common number of oxygens, which you just have to memorize. So going back to our previous slide, right, you see SO4. You have to know that SO4 gets the common number of oxygen suffix, which is 8. And then SO3 gets the ite, SO2 gets the hypoite. They're just things that you need to memorize. Now remember, I'm going to give you your polyatomic ion sheet on your unit exam. So now let's go through some ternary salt practice. The first is Na2SO4. Well, we know SO4 is one of the common ions that we need to memorize. That's a sulfate. We check it, is it O4? Well then yeah, that's the 8 suffix because sulfate is SO4. So then that's sodium, Na is sodium, so we get sodium sulfate, right? We don't change the ending to IDE anymore. So with polyatomics, we leave the suffix the way it is. Well, then now we look down at magnesium, but now we know we had sulfate, nitrate, chlorate, bromate, phosphate, and carbonate, right? Those were the things that we had to memorize. Well, what was nitrate? Nitrate was NO3. So going back to this slide, NO3 was nitrate, so then NO2 is one fewer oxygen than common. That means that you get magnesium nitrite. So you attach the ITE suffix. Now the reason why we don't care about that 2 subscript outside the NO2 is because we should automatically be able to know the oxidation state of magnesium, right? It's in group 2, therefore we get a +2 oxidation state. We don't need to say dinitrite or anything like that. These should all be common known. There's no multiple oxidation states right here. So now this is calcium phosphate, right? We know phosphate because that was the one that we had to memorize. We know that that was PO4, so then we stick with the 8 suffix. Lithium phosphate, what's the charge on lithium? Well, lithium is +1, phosphate is -3. We swap oxidation states. That means lithium 3, PO4 PO4 1, right? What about aluminum perchlorate? So, okay, so we imagine in our head, we had to figure out sulfate, which was -2, Then we had to figure out chlorate, which was ClO3, 1 minus, bromate, BrO3, 1 minus, nitrate, that was a minus. Then we had phosphate, which was 3 minus, and then we had carbonate, which was 2 minus. This is closely related to chlorate, but how does it change? It has a per suffix. It has a per prefix. So then you look up at the table and you say, oh, that's per, right? And then we have chlorate, which means one more oxygen than common. So chlorate was with ClO3. So then what does this become? That's aluminum ClO4. Well, now we have to figure out the charges. So perchlorate has a charge of -1. Aluminum has a charge of +3. So that's AlClO3O43, right? So we're just working through this. Beryllium hypobromite. Bromate is BrO3. Hypoite is 2 less than common, so that's BrO. Beryllium hypobromite, BeBrO2, right? Because beryllium has an oxidation state of +2, so you work through that, right? So now, moving on from ternary salts to ternary acids. So we're going to go through ternary acids now and then through ternary acid salts. So if you look at this, right, H2CO4 is related to CO3, which is the carbonate ion, right? So we have carbonic acid. So we changed the suffix from ate to ic, and we added the word acid. We added, so this is the percarbonate anion, so we changed ate to ic and added acid. So now it's the same thing for HClO4 and HSO4, but now look down at SO3, right? That's 1 less oxygen than common, which means that should be the ite suffix. So now ite turns into us, right? So sulfite turns into sulfurous acid, right? So then we have BrO4, which is perbromate, which turns into perbromic acid. The bromate ion turns into bromic acid. BrO2 is bromite, so that's the bromous acid. Then BrO is hypobromite, which it's hypobromous acid. So these, we just change the suffix. Ate becomes ic, ite becomes us, and we add the acid. You might be asking, well, how do we identify an acid? Well, as you can see, the binary acids and ternary acid identification is the exact same. It has H out in front of the chemical formula, which means it's an acid. So we just identify, if we have HCl, we identify that as a binary acid. If we have H2SO4, we identify that as a ternary acid, or a polyatomic acid, or your book will call them oxyacids. So then we transform ate into ic, ite into us, and we add the word acid at the end. It does not depend on state. All of these are changed. It's not hydrogen sulfate, and then when it doesn't matter. You automatically turn ate into ic and add the word acid. So the sulfate ion becomes sulfuric acid. Hypochlorite becomes hypochlorous acid, right? So then now, before we start our practice, we're going to go over ternary acid salt, because this is just an extension. So now, if we strip one of those hydrogens away and plug in a sodium, now we have sodium with a +1 oxidation state, hydrogen with a +1 oxidation state, carbonate with a -2. That balances out, so we have sodium, hydrogen, carbonate. That's how we can name it. We can name it sodium, hydrogen, then name the anion, which is carbonate. Or, old school way of naming it, just like the old school way of naming transition metal compounds, we can say sodium bicarbonate. The bi stands for hydrogen. Don't ask me why. It's an old school way of naming hydrogen. Sodium bicarbonate, right? So we just have to transform that name, right? So if we take away a hydrogen and add a metal, we get a ternary acid salt. So it's an acid form, right? HCO3 would have a -1 anion or oxidation state. So then that sodium can balance it out. So we get a ternary acid, but that's composed that's ionically bonded, so it's actually a salt. So ternary acid salt, you name the metal, then hydrogen, then the polyatomic. So now if we had NaHCO2 it would be sodium hydrogen carbonate, right? So now let's go through a couple of these. We have BaBrO3, 2. So now we have BrO3, which from our memorization, we know that's the bromate ion, right? So this is a ternary salt, so we just name the metal and then the anion, which is barium bromate. Now, BrO3 is the 8 suffix, which means that's the common number. So then BrO is 2 less than common, which means that's hypobromite, right? So we just have to memorize bromate and then take it and subtract 2, which that gets the hypoite prefix and suffix. So then now this is sodium, and you look at it and you say that's IO4, so that's sodium periodate, because IO3 gets the iodate. So then IO4 is per 8. So then now we have H2CO3. This is a ternary acid, right? How we identified that was it doesn't have a metal and it just has hydrogen and an ion, which means this is the carbonate anion, which means 8 becomes ic, so that's carbonic acid, right? Now, here at KHSO4, we have potassium, a hydrogen, and then a polyatomic, which means this is a ternary acid salt. So this is potassium, hydrogen, sulfate, or potassium bisulfate, right? So we can name it both ways. So then now we're looking down here, and this is H3PO4, no metal, so this is a ternary acid. So now we have to locate the anion form, which is the phosphate, right? We're taking the polyatomic, we're taking the oxyacid, the phosphate, and we're turning 8 into ic, and this is phosphoric acid, right? Looking down one more, we have the nitrate polyatomic. So then we combine that with an iron, and now we need to think a little bit, because now we need to name this like a binary transition metal, right? So now we need to locate the oxidation state of iron, which if you look at the subscript of nitrate is 2, so we can move that up and we can say iron 2 nitrate, right? Now looking down one more, we can move the 3 up and the 2 up. We can cross those, and we find that the oxidation state of iron is 3. That's the sulfite. That's the sulfite polyatomic, because that's 1 less than SO, or that's 2 less than SO4, which means that's this hyposulfite. So we get iron 3 hyposulfite. Then we have NH4ClO3, right? This is ammonium, the polyatomic ammonium, and then we have ClO3, which is the chlorate polyatomic. So this is ammonium chlorate. Moving on, we have lithium nitrate. Nitrate is NO3 with a -1 oxidation state. Again, something you have to memorize. Lithium has a +1 oxidation state, so that's LiNO3. What about lithium hydrogen sulfate? Well, now we look and we say lithium, and then listed as hydrogen, and then a polyatomic. Well, that's a ternary acid salt. So we get LiHSO4, right? How we knew SO4 is because of the 8 suffix. 8 means common number, which is 4 in the case of sulfur. What about magnesium bicarbonate? Well, magnesium has an oxidation state of +2. The bicarbonate ion, you have CO3, the carbonate polyatomic, has an oxidation state of 2-, but now you're combining it with an H, which has an oxidation state of +1, which means the bicarbonate polyatomic, or the bicarbonate anion, has a -1 oxidation state. Magnesium +2, you switch, you get magnesium, HCO3 2, right? So then nitrous acid, you have to work back if it's a ternary acid. So you have to go ite become us. So then that's the nitrite anion, right? The nitrite polyatomic. So then now we have a -1 oxidation state. So then nitrite ite becomes us. So then we get nitrous acid. So that's HNO2, right? So that concludes our polyatomics. The biggest thing is memorization. A lot of students run into this and they say, "Oh my gosh, this is terribly complicated." Well, it just seems that way right now because you haven't taken the time to memorize everything. Once you've memorized the oxidation state and the chemical formula for sulfate, nitrate, chlorate, bromate, phosphate, and carbonate, all of this becomes much simpler. But until you memorize those things and internalize that information, well, then it seems very complicated. I understand that. It seems very difficult. But once memorized, these naming conventions are very easy to pick up on.